Vertical position of a ball at time t seconds after throwing the ball upwards is given by yt equals to negative 16t squared plus 96t plus 40 feet. So what the situation right now is that you're throwing the ball upwards, and at some point it's going to fall back. When it's going up, because the height is increasing, we will say the speed is positive. And when it's coming down, because the height y is decreasing, we know that the speed is negative. Okay, first question, what is its initial velocity? What is a velocity? Velocity is the rate of change of the position. So we know that v is equals to dy dt. It's the rate of change of y with respect to time t. This is just the Leibniz notation for the derivative, so we just have to differentiate the right side. Okay, first of all, t squared differentiates to 2t, so we have to multiply negative 16 to 2t, and then t differentiates to 1, and because 40 is a constant, it differentiates to 0. So we know that the velocity is negative 32t plus 96. But here it's asking for the initial velocity. What is that? That's the velocity at time t equals to 0. This bar here can be read as at or when. Velocity when time t is equal to 0. And it simply means that after calculating this quantity, you have to plug in whatever it's under here. So we will be plugging in t equals to 0 into this function. If I plug in t equals to 0 to this function, 0 times 32 is 0, so you only get 96 as your answer. Now let's think about what unit to use. The unit for y is feet, and because you're dividing y by dt and t's unit is seconds, the unit should be 96 feet per second. Second question, question B, what is its acceleration? Is it constant? What's an acceleration? Acceleration is the rate of change of velocity. It's looking for how fast the velocity is changing, and since velocity is negative 32t plus 96, we have to differentiate this. Differentiating t gives you 1, and 96 is a constant, so if you differentiate, it's 0. So you only get negative 32 as its derivative, so acceleration is negative 32. And since velocity has a unit of feet per second, and you're dividing this again by another second, so it's seconds squared. Okay. Question C, what is the maximum height the ball can reach? Okay, what is the maximum height the ball will reach? Alright, so we're looking at this ball going up, and at some point it's going to turn around and fall back. This is the point where it's highest, and when it turns around, the velocity becomes 0, and that's the one that you want to use in order to figure out when this happens. So let's set the velocity equal to 0, negative 32t plus 96 equal to 0. Solving for this, you get t equals to 96 divided by 32, which is equals to 3. And this is not the answer yet, because it's not asking for when the ball will reach the maximum height. It's asking for the maximum height itself. And since y holds the data of the maximum height, we have to evaluate y at time t equals to 3. Okay, so let's see what that gives us. We have to plug in 3 to that function, and if you multiply these out or calculate using a calculator, you'll see that the answer for this is, I think it's 264 feet. Okay. Now I still have 2 more questions to ask, actually 2 more important questions. Part D is, what is the velocity at 2 seconds after the throw? Well, that's like asking what is the velocity at time 2. So since we have 32t plus 96, and we have to plug in t equals to 2 into it, we end up with negative 64 plus 96, giving you 32 feet per second. And E is actually the most important question, I think, because it's the one that's the most misunderstood. Okay, and the misunderstood thing here is the average velocity. What is this average velocity? Well, students seem to misunderstand average velocity as you take the velocity at time t equals to 0 and velocity at time t equals to 2 and take the average. And sometimes they even gives you the correct answer, but it's only true for certain cases. The average velocity is really the average of the velocity during the entire trip, not just the beginning and the end. And it just happens that for constant acceleration motion, the average velocity is same as the average of the two velocities of the beginning and the end. But even if that's true, it's not something that I should be doing. I want to solve this in the correct way. So let me write this down. The average velocity, usually average is you put a bar over to indicate it's the average velocity. Average velocity is the change of the position divided by the change of time. So this has nothing to do with the derivative, and people use derivatives thinking that that's what they want and get this question wrong. Okay, so let's think about this. We really want to know the position at time 2 minus position at time 0, because terminal minus initial gives you the change in that quantity. And because we're doing the first 2 seconds, we're thinking about time 0 as the initial and the terminal time is 2. Okay, so we're thinking about 2 times here. Time t equals to 0, time t equals to 2, and we are trying to take the difference of the position between the 2 times. Okay, so if I plug in 2 to this, I get, let's see, negative 64, 192 minus 64, that's 8, 128 plus 40, that's 168. And then if you subtract y of 0, what's y of 0? If I plug in 0, that's 40. And then you divide by the entire time period, which is 2. And that's 128 divided by 2, and that gives you 64 feet per second. Okay, so that is called the average velocity for the first 2 seconds.